So in my third and the final video, I'm going to tell you the concept of pivots. Pivots. What basically is pivot? Pivot is a leading non-zero entry in a row-reduced form of a matrix. Let's see what its pivot is. Our previous matrix was 3, 1, 2, 5, 1, 2, minus 1, 1, sorry 2, 4, 3, 1, 7. This is the original matrix, and we have used Gaussian elimination method to convert it into a row reduced form. So our row reduced matrix was this is our matrix A, and let's denote our row reduced matrix with B. Our row reduced matrix was 3, 1, 2, 5, 0, 5, minus 5, and 1, 0, 0, sorry, 0, 0, 0. You can go to our previous my previous video and check whether this was correct or not. I think this was only the reduced form of our matrix. So now, in my previous video, I have told you that these are the leading non-zero elements of a row-reduced form of a matrix. So what basically pivot is these non-zero elements. So in pivots, we have pivot columns, pivot values, pivot variables, and free variables. Let us begin with pivot variables. Pivot columns. We will begin with pivot columns. What are pivot columns? The columns in which the non-zero entry is there. Here, first column and second column, because non-zero element entry of the first row is 3 and non-zero entry of second row is 5. 3 is in first column and 5 is in second column. So our pivot columns are column 1 and column 2. What are our pivot values? Our pivot values are 3 and 5. What are pivot variables? See, we will denote first column is X, second is Y, third is Z, and fourth is HAP, because while solving equations we need 4 variables and some equations will be there. So pivot variables are those variables in which pivot is formed. That is, the first column and the second column variables are pivot variables. So our pivot variables are X and Y. Since we have denoted first column as for X, second for Y, third for Z, and last for P. So our pivot variables are X and Y. Free variables. Free variables are basically the variables which are not pivot, that is Z and P. These are our pivot variables. Since we have 4 columns, 4 variables, so 2 are pivot here and 2 are free. Now let's see what is rank of a matrix. Rank. Rank is basically the number of pivot values or number of pivot columns. All these can consider a rank. So rank is number of pivots formed in a row reduced form of matrix. So here rank is number of pivots in a row reduced matrix. So here pivots, 2 pivots are there in this matrix. 2 pivots are there, so rank will also be 2, since number of pivots are 2 and rank will also be 2. For finding the rank, we can simply use the keyword rank and matrix A. Our basic matrix was matrix A, so rank of matrix will be 2. Here rank of matrix is 2, and hence it is proved that manually or through using MATLAB, the rank of matrix will be number of pivots in a row reduced matrix. So in our previous videos, we have seen how to create a matrix, how to convert a matrix into row reduced form, what are pivots, and that's all. Thank you.